This video is a review of right triangle trigonometry. So why trig? Why right triangle trig? Well, if you're a carpenter and you're building a house, you're probably going to have a roof with some kind of angle to it. So you need to know how long to make the sticks that are going to make the roof, or what kind of angle you're going to make it, because if you're living up in a cold climate, it'll be a steep angle. If you're living in a warmer climate, it'll be a more shallow angle. Or perhaps it's just an architectural choice. So you've got to know some trigs to make a triangle and figure out some angles and lengths. Or maybe you want to build a better ramp for a motorcycle loading on the back of a truck. You got to know trig to figure out some lengths and some angles. Perhaps you're going to use that motorcycle to make a big jump. Well, if you're going to do that, you've got to do some trig so you know the angle that you're going to leave the ground with. That way you'll know how high you're going to travel and where you're going to land. Or perhaps you're a cannonballer. You need to know the angle that you're being shot out of a cannon so you'll know where to place the net. Or maybe you're just an architect that's building a handicap accessible ramp. Again, you're going to need to know some trigs so you can figure out some angles, because you've got to make sure the angle's not too great, something that's very manageable. Or perhaps you're an aerospace engineer and you're designing the next best thing. So you got to know some trig because you got lots of angles in your design. Perhaps you're a forest ranger and you need to know the height of a tree, and you will need to know the height of the trees. So to do that, you're going to use some trig and some other estimations to figure out the height of the tree. So there are lots of ways of using trig, and we're only going to use a small part of the mathematics of trigonometry. We're only dealing with right triangles and three functions, so it's going to be easy. A right triangle is any triangle that has a right angle to it, and any line that you draw you can turn into a right triangle by drawing the other two lines to make it a triangle. So here's my right triangle. The little square in the bottom represents 90 degrees, and theta, it's the Greek letter of the alphabet, and that's the variable we're going to use that stands for an angle. So every time I talk about theta, I'm actually going to talk about an angle. Now, the triangle has three sides, and each side has a name. The side opposite 90 degrees, and it's the longest side of the triangle, is called the hypotenuse. It's the easiest one to identify. The other two sides are relative to the angle. So the first one is called the opposite side, and it's opposite the side opposite the angle, theta. So that's the opposite side. The next side is called the adjacent side. Adjacent is another word meaning next to. So the adjacent side is next to theta. Now if I move theta, and this is why it's called relative names, because the names change. So now the names are swapped, and the side that's next to theta is the adjacent side, and the side that's opposite theta, well, that's called the opposite side. So the adjacent and the opposite are relative to where you put theta, but the hypotenuse is the hypotenuse. It's always along the side. It's always opposite 90 degrees. So that's an easy one to identify. You need to be able to identify which side is which in order to use the trig functions. We're only going to use three functions. We're going to use sine, cosine, and tangent. On the calculator, they appear as sin, cos, and tan. So what we do is we press sine, and then we're going to have an angle. So sine of theta, cosine of theta, tangent of theta. And I'll push that in the calculator, and the calculator will give me a number back. And those numbers are going to be ratios. So for example, if I have a triangle, and I put theta in the lower left-hand corner of this triangle, then that would be the hypotenuse, and that would be the opposite side. So when I put sine of whatever the angle is, let's say it's 15 degrees, it'll give me a number. That number is a ratio of the length of the opposite side divided by the length of the hypotenuse. And if I move theta, then everything changes in terms of my labels. Now there's the hypotenuse and the opposite, but the ratio stays the same. So opposite side, hypotenuse side. And you're wondering, how can these two be the same? Well, remember, they're different angles. In fact, these two angles are complementary angles to each other. Cosine works the same way. It's a ratio of the adjacent side length divided by the hypotenuse side length. So in a triangle, once I find theta, if I know the adjacent side and know the hypotenuse, I just take the adjacent side's length divided by the hypotenuse side's length, and that'll give me a number that the calculator tells me is cosine theta. And if I put the angle somewhere else, I redefine everything. And remember, when I put it up in the other corner of the triangle, it's the complementary angle. And finally, for the tangent function, it's the opposite side length divided by the adjacent side length. So here's theta, here's the opposite side and the adjacent side. If I take the opposite side length divided by the adjacent side, it equals tangent of whatever that angle is, theta. If I move theta, it's still the same relationship between opposite and adjacent. So what we know is that the sine theta is the ratio of opposite side length over hypotenuse, cosine's adjacent over hypotenuse, tangent opposite over adjacent. This is a lot to memorize, so we have a little mnemonic to help you remember. We take the first letter of each one of these sentences and put it together into a little kind of phrase or word. First part of it, SOH, so. Second part, cosine adjacent over hypotenuse, CAH. Third part, tangent, opposite over adjacent. So, tangent, opposite over adjacent. TOA. So, ka, TOA. So ka, TOA is our little mnemonic device to help us remember the functions and the relationships to the ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. So let's practice a little bit. So I'm going to use the trig functions on your calculator, and I'm going to find the length of the unknown side. So I have an angle at the top that's 28 degrees, I have a side that's 10, and then I have x. X is the unknown length I'm looking for. My process for finding this out using trig is I'm going to identify the sides as opposite, adjacent, or hypotenuse. Remember, give them my labels. And I'm going to use this process of elimination to figure out which trig function to use. In other words, sine, cosine, tangent, which one should I use using my mnemonic, so ka, TOA. And then I'll plug the numbers and check out the answer, just straightforward. First, let's identify the sides. Opposite the angle, x, that's going to be called the opposite side. And next to the angle, well, that's called the adjacent side. That's what adjacent means, next to. So 10 is the adjacent side. Now, process of elimination, I've got my three trig functions, so, ka, and TOA. Which one of these has O and A in it? Tangent. Tangent has opposite and adjacent in it. So I'm going to use the tangent function to figure out the answer. So tangent of theta is equal to opposite side length divided by the adjacent side length. So the tangent of 28 degrees is equal to the opposite side length, which is x, divided by the adjacent side, which is 10. So when I do the math, x comes up to be 5.32. Now in the calculator, it looks something like this. So here's the calculator. The screen's going to look like this when I'm done. 10 times tangent 28. So I'm going to use the tangent function, which is right here on your calculator. 10 times tangent 28, and then I'm going to add the last parentheses on the right-hand side of that. And that'll give me the 5.32 with a few more decimals. So let's practice a little bit more and find the length of another unknown side. So this is the adjacent side. 10 is next to 58. And x, that's the longest side of the triangle, so that's the hypotenuse. Now what I need to do is look at my mnemonic, so, ka, TOA, and figure out which one of these has adjacent and hypotenuse. Well, adjacent and hypotenuse, that's the cosine function. So cosine is equal to length of the adjacent side divided by hypotenuse side length. So cosine 58 degrees is equal to 10 over x. So multiply both sides by x, then divide both sides by cosine 58 degrees, and that gives me 18.87. On the calculator, your screen's going to look something like this. Well, I'll use the cosine function, which you can see right there, and your screen's going to look like this. 10 divided by cosine 58, and I've got that parentheses closing off 58. Now you really don't need the parentheses on the end of the 58, but it's just a good practice to do that sometime. You'll see why later. Alright, so let's find the length of this unknown side. Alright, identify the sides. So it's 48 degrees. The 8 is across from 48. It's not the hypotenuse, because it's not across from the 90, it's just across from 48, so that makes it the opposite side. The hypotenuse is across from the 90-degree angle. It's also the longest side of the triangle, and that's what x is. So x is the hypotenuse. So I need a trig function, think about so, ka, TOA, that has hypotenuse and opposite. That would be sine. So sine is the length of the opposite side divided by the length of the hypotenuse side. So therefore sine 48 degrees is equal to 8, which is opposite, over x. Multiply both sides by x, divide by sine 48, then do the math in my calculator to get 10.77 for the length. Now there's a few more decimal places, but 10.77. So this time on the calculator, I'm using the sine function. And my screen is going to look something like this when I'm done. 8 slash sine 48 in parentheses. So now let's look about how to work backwards. How do I find the angle given the sides? Well, to do that, instead of using sine, cosine, tangent, I'm going to use what's called the arc sine, arc tangent, or I'm sorry, arc cosine, or arc tangent. Sometimes people refer to this as inverse sine, inverse cosine, inverse tangent because of the way it's written and the way it's shown on the calculator. But it's really not the inverse. It's actually arc sine, arc cosine, arc tangent. But we'll go with the terminology of inverse sine, inverse cosine, inverse tangent. So I'll look at my triangle and I can identify my sides just like before. The 6 is across from theta, so that's going to make the 6 the opposite side. The 10 is next to theta, or adjacent to theta, so the 10 is the adjacent side. So I need a function in my SOHCAHTOA that is opposite over adjacent. So that's the tangent function. So tangent of theta is equal to 6 times 10. Now to put theta all by itself, what you do is you're going to perform a function on both sides of it, and that's the arctangent function. But arctangent instead of tangent goes away, kind of like inverses do. So it makes sense. So theta is equal to arctan of 6 divided by 10, or theta is equal to inverse tangent of 6 divided by 10. And that's going to equal 30.96. So in the calculator, what I'm doing to get the arctangent is I'm going to use the blue buttons. So I'm going to start by hitting the second button. And then if I get rid of all the buttons you can see and look above them, you'll see there's an inverse tangent button. And that's the one I'm going for. So I'll press second tan, and that'll access that function right there on my calculator. So second, and then tan, and that'll be the inverse tangent function on my calculator. So when I do that, my calculator screen will look something like this. Tangent -1, parentheses, 6 divided by 10, and then I've got to add this other parentheses. If I don't add the other parentheses, I'll get the wrong answer. It'll come as tangent inverse tangent of 6. It'll get an answer, and it'll take that answer and divide it by 10. So you need to put the parentheses on the right-hand side. That's why that was a good practice before of always closing your parentheses by putting the parentheses on the right-hand side, because in something like this, you'll avoid a careless mistake. So remember, when finding the angles, use the arcsine, arccosine, or arctangent.